Okay, so problem 4 is asking about a solid turntable, which is a uniform disk of radius r and mass m that rotates on frictionless bearings about an axis through its center. So two masses fall on opposite ends of this disk, both falling at distance r/2. And the problem is asking us to find the angular velocity after the two cubes or masses fall onto the turntable. So the two main concepts that are going to be important for the situation are the conservation of angular momentum and inelastic collisions. So when it comes to conservation of angular momentum, we know that the initial angular momentum is going to equal the final, and this just having some extra knowledge about the nature of inelastic collisions can also be helpful. So the one thing I wanted to say really quickly is that the problem indicates that there is no velocity component in the transverse plane for those falling blocks initially. So once we start setting this up, you can see that our initial momentum, L, is just going to be the moment of inertia of the rotating disk times the initial angular velocity. And so the moment of inertia for a cylinder is 1/2 mr squared. So that's all you have to do, just plug that in. So now the harder part is solving for the final momentum. So the final momentum is going to be equal to 1/2 mr squared times omega final this time because the speed is changed due to the blocks. And then you have to multiply that by the added, or rather the angular momentum of now the two cubes, which is why I have a 2 in front of the inertia of the cubes times omega final in that equation, because they're going to contribute in identical ways to this. So notably that Im is inertia due to the masses is going to be m, because we know the moment of inertia is mr squared. So we were told in this case that the blocks land at r/2. So instead I just plugged in r/2 and solved that. That moment of inertia is going to be m times r squared over 4. And then you can go ahead and just plug that back in, which you can see I continued with in that bottom section. And a lot of stuff can be factored out, which will make simplifying later easier. So I did that, giving us L final equals omega final squared, or not squared, omega final times r squared over 2 plus big M plus small m. So now we're just going to set that initial momentum equal to the final. And a lot cancels, the radius cancels, the 1/2 cancels, and we can eventually simplify that down to omega final being equal to the mass of the turntable times the initial momentum, initial angular velocity rather, of the turntable over the mass of the cube plus, once again, the mass of that turntable. So that is this problem. Thank you for listening.